It happens faster than light can cross the orbit. A passing star moves through the outer solar system, or a gas giant in another system, reaching across millions of years of orbital chaos, pulls the wrong way at the wrong moment. The mechanism varies, the result does not. The gravitational ledger gets rewritten, the sun loosens its grip. Earth, still moving at 30 kilometers per second, the same speed it has carried for 4.5 billion years, keeps going. The orbit was always an illusion of permanence, a curve made of gravity. When the gravity yields, the curve straightens, the straightened line points away from the sun, and Earth, finally, takes it. For the first few days, nothing on the surface looks different. The sun rises smaller every morning, but the change is slow enough that you would have to be watching for it. Tides keep pulling, storms keep turning, animals do not look up. And underneath all of it, quietly, the temperature is already dropping. This is the beginning. Not of the end, of the long after. What we're doing tonight is following a planet that has been pushed out of its star system. Earth. Ejected. Not destroyed, ejected. There is a difference. Most of what people imagine about this scenario turns out to be wrong, and the actual physics is stranger and quieter than the disaster usually pictured. By the time we are done tonight, the night sky is going to look different, because the night sky is already full of these. Planets like ours, drifting alone in the dark between stars. Most of them no instrument will ever find. Most of them no one is ever going to see. A star moves through the outer dark of the solar system, not a close star, not even a visible one from where Earth's astronomers stand. A red dwarf, half the mass of the Sun, threading through the far edge of the Oort cloud at a distance of 1 light year. It does not collide with anything. It does not need to. Its gravity, weak at that range but not zero, tugs on a sea of icy bodies that no human eye has ever seen. The Oort cloud, the outermost shell of the solar system, extends to roughly 100,000 astronomical units. That is roughly 1.5 light years. The far edge of the solar system is closer to the next star than the Earth is to the Sun by a factor of more than 100,000. The red dwarf, drifting past, does not have to disturb the Earth directly. It only has to disturb the ledger. Every body in the solar system, from Mercury to the smallest comet on a 100 million year orbit, is held in place by a balance. The Sun pulls inward, the orbital velocity carries each body sideways. Subtract a small amount of pull or add a small amount of sideways motion, and the balance changes, the numbers shift. Some bodies fall inward, some bodies, given the right perturbation, swing outward into new orbits, and some, given enough of a push at the right moment, swing outward and never return. Stellar flybys at this distance are not rare. The Sun has had several. Skolce's star passed within roughly 70,000 astronomical units of the Sun about 70,000 years ago, deep inside the Oort cloud, possibly close enough to have nudged comets into long, slow inward trajectories that are still in motion. Gliese 710, currently 53 light-years away, is heading our way at a speed that will bring it within 1/10 of a light-year of the Sun in about 1.33 million years. The galaxy already does this. It has always done this. Stars are not stationary. They drift through the disk of the Milky Way at speeds ranging from a few kilometers per second to hundreds, on orbits that take hundreds of millions of years to complete. On those orbits they pass each other, the way ships pass at sea, except the ships are stars, and the sea is a galaxy, and most of the passing happens too slowly for anyone to notice. For the solar system, almost all of those passes happen too far away to matter. A red dwarf at 1 light-year tugs gently. A red dwarf at 1/10 of a light-year tugs harder. A star passing through the inner Oort cloud, 10,000 astronomical units out, would not just nudge a few comets. It would reshape the orbits of everything within reach. And yet the Earth, at 1 astronomical unit from the Sun, would still not feel the pull directly. The geometry doesn't work that way. The Earth is too tightly bound to the Sun at this distance for a passing star to simply pluck it loose. The Sun's grip at 1 astronomical unit is strong. Solar escape velocity at Earth's orbit is 42.1 kilometers per second. The Earth is moving at 29.8. To leave the Sun, Earth would need an additional 12 kilometers per second, more or less depending on direction. 12 kilometers per second is not a small adjustment. A passing star a light year away cannot provide it. So how does the Earth leave? It leaves the same way most things in the universe move from one state to another, indirectly, through a chain, through the perturbation of larger bodies, which then perturb smaller bodies, which then accumulate into a single decisive event. The Earth is held by the Sun, but the Earth is also nudged, every orbit, every century, by Jupiter. Jupiter is a planet large enough that its gravity organizes the asteroid belt, shapes the orbits of comets, and protects the inner solar system from many of the impacts that would otherwise reach it. Jupiter is the heavy weight at the center of the dance. Move Jupiter, and everything inside Jupiter's orbit gets moved with it. Move Jupiter enough, and the inner solar system stops being a stable arrangement of nearly circular orbits and becomes a chaotic system of interacting bodies on diverging paths. This is not hypothesis. This is the early history of the solar system itself. Simulations of the first few 100 million years after the planets formed suggest that the gas giants migrated, that smaller bodies were ejected wholesale, and that the solar system likely had a 5th gas giant which was lost to interstellar space during a period of orbital scattering, an ice giant. Ejected, gone. The mathematics says it left. Where it went, no telescope can answer. It is out there somewhere, on a course set 4.5 billion years ago, and it has been crossing the dark since before the first cell on Earth made copies of itself. Other systems do this routinely. Of the thousands of exoplanets catalogued in the last 3 decades, a large fraction sit on orbits that suggest violent histories. Hot Jupiters, gas giants in tight orbits around their parent stars, almost certainly didn't form where they are. They migrated. Some of them migrated by interacting with other planets. Some of those other planets were thrown out. The early life of any planetary system is in part a process of subtraction. Planets get launched. The system settles. The ones that stay are the ones that by luck or by mass didn't get pushed. Right now, as you're listening, the galaxy is performing this subtraction somewhere among the hundreds of billions of star systems in the Milky Way, with their young planets still settling into stable orbits and their old systems still vulnerable to the occasional passing star. The ejection of a world is not a rare cosmic accident waiting to happen. It is something the galaxy does continuously, the way a forest continuously drops leaves, the way a city continuously loses and gains residents. At this exact moment, in some system whose light has not yet reached Earth and never will mean anything to anyone here, a planet is being pried loose from its star and set on a one-way path into the dark. It has happened countless times already. It is happening now. It will keep happening for as long as the galaxy turns. The Earth, 4.5 billion years in, looks settled. The orbit is nearly circular. The system, post-violence, is stable. The chaos has been gone for billions of years. And yet the chaos has not promised to stay gone. A future stellar flyby, particularly a close one, can reintroduce it. A passing star tugs on Jupiter, just slightly. Jupiter jostled, tugs on Saturn just slightly. Saturn jostled, tugs on the next thing. The chain begins. The chain takes time. Sometimes the chain takes millions of years to play out, sometimes tens of millions. The result, if the geometry is bad enough, is that an inner planet finds itself with a Jupiter-altered orbit that crosses the orbits of the other inner planets. From there, the system becomes unstable. From there, the inner planets begin to scatter. And from there, a planet can be lost. The kicks happen one at a time. A close encounter with another planet exchanges energy. One body slows, the other speeds up. Repeat this enough times, with enough random geometry, and one of those bodies gains enough velocity to exceed solar escape velocity. The other bodies might fall into the Sun, they might get pushed into Jupiter, they might settle into new orbits that the previous astronomy would not recognize. The bookkeeping is brutal. It balances. There is a strange economy to it. Energy and momentum are conserved, always, in every gravitational encounter, which means that for one body to be flung outward and gain the energy it needs to leave, another body must give up an equal measure, falling inward or settling into a tighter orbit. The ejected planet does not get its escape for free. It steals it in a series of small thefts from the rest of the system. Each near miss with another world is a transaction. Energy passed from one body to another, across the empty space between them, mediated by gravity, settled instantly and exactly. The planet that leaves is the one that, by the accumulated luck of many such transactions, ended up holding more energy than the Sun's grip could contain. The planets that stay are the ones that paid for its departure. The ledger across the whole system comes out even. It always does. Gravity does not lose track. What makes this scenario, the ejection of a fully formed terrestrial planet in a settled system, statistically rare is the timescale and the geometry. Most stellar flybys are too distant to matter. Most distant flybys produce small disturbances that decay across the system without amplifying. Most of the time, nothing happens. But most of the time is not all of the time, and the galaxy has been doing this for 13 billion years. In any given star's history, the chance of a close enough flyby producing a chain that ejects an inner planet is small. Across the galaxy, across the lifetime of the disk, across the population of stars and the number of planetary systems they hold, the small chance becomes a large total. The mathematics of rare events meeting large populations. The same mathematics that says any given person will not be struck by lightning, but at any given moment, somewhere on Earth, someone is. For the Earth, the trigger could be a stellar flyby. It could be the slow accumulation of resonant tugs from Jupiter and the outer planets that, over very long timescales, slowly destabilizes the inner orbits. It could be an encounter with a rogue body, one of the many free-floating objects already drifting through interstellar space, passing close enough to perturb the system without ever being seen. It could be any of these. The fact that no instrument can predict which doesn't change the result. The mechanism is one of several. The outcome is one. The outcome is that at some specific moment, after a chain of events that may have taken hundreds of thousands or millions of years to set up, the Earth's orbital geometry shifts enough that the planet's velocity vector, when integrated forward, no longer closes. The orbit, which was a closed curve, becomes an open one. The closed curve was an ellipse. The open curve is a hyperbola. Mathematically, the planet is no longer bound. Physically, what this means is that the Earth on its next pass close to the Sun no longer slows enough to swing back. It keeps moving. The Sun pulls, but not enough. The Earth, accelerating slightly as it falls inward, accelerates also outward as it climbs away. The kinetic energy is now greater than the gravitational potential energy that would be needed to bring it home. The math is final. The Earth does not know any of this. The Earth doesn't know anything. The Sun keeps rising and setting. The seasons turn, the atmosphere holds, the biosphere ticks along the way it has ticked along for hundreds of millions of years. The orbit, traced in the cold language of physics, has already broken. This is the part of the story that the imagination usually misses. There is no impact, no flash, no moment that anyone on Earth's surface would identify as the moment. The day on which the orbit becomes unbound looks like every other day. The Sun is in the same place in the sky. The sky is the same colour. The wind moves the same trees, and the planet has already left. It is weather in the deepest sense. A long accumulation of small inputs each one too small to feel, until one morning the conditions stack and the system, which had been one thing, is now another. The storm is not the moment when the storm becomes visible. The storm is the moment when, the conditions having accumulated, the storm becomes inevitable. The conditions have stacked. The orbit, viewed from far enough away to see the whole curve, is no longer a curve. It is a line bending only because it hasn't finished bending yet. Given time, it will straighten. The line points away, and the curve was never permanent. It was only borrowed. Draw the path on black paper, a white line that bends gently, almost into a circle, around a single point of light. That is the orbit, the curve it has been for 4.5 billion years. Now take a pen and continue the line forward in time. The bend that used to come back doesn't. The line straightens, the point of light stays where it is. The line keeps going. This is what ejection looks like when the math finishes. Earth doesn't fall anywhere. Earth travels. The destination is not out there in the abstract. The destination is a specific direction, at a specific speed, into a specific region of the galaxy that the planet has never been near before. The trajectory passes the orbit of Mars in a few months, the asteroid belt in less than a year, Jupiter in a few years, Saturn in roughly a decade, Uranus and Neptune in the decades after that, the Kuiper belt within a few centuries, and then the long crossing of the Oort cloud, which the planet enters as one more body among trillions and exits, after 15 or 20,000 years, into the dark. The dark is not empty either. We'll come back to that. What carries the Earth out is not propulsion. There is no engine, no push, no force adding velocity after the moment of ejection. The Earth leaves on the speed it already had. Right now, the planet beneath you is moving at 30 kilometers per second. It has been moving that way your entire life. It has been moving that way for 4.5 billion years. That speed has always carried the Earth on the same path because the Sun has always pulled it back. Velocity outward, gravity inward, balanced into a closed loop. Take the gravity away, or weaken it just enough, and the velocity that used to make the curve now makes a line. The image works better with a thrown rope. A ball at the end of a rope, spinning in a wide arc above someone's head. The ball is moving fast. It looks like it is held in a circle. But the circle is not what is happening. The ball is moving in a straight line. The rope, every instant, bends that line back toward the center. The motion the ball wants to make is a tangent. The motion the ball is allowed to make is a curve. Cut the rope. The ball does not slow down. The ball does not fly outward. The ball does what it was always doing. It moves in the direction it was already going at the moment the rope released. For Earth, the rope is gravity. The tangent is the trajectory. This is the part the word orbit hides. An orbit sounds like a track, a groove the planet sits in, a path built into the structure of the solar system, the way a rail is built into the ground. It is nothing of the kind. There is no track, there is no groove. There is only a planet moving in a straight line, and a sun bending that line, instant by instant, into a curve that happens to close on itself. The orbit is not a thing the Earth rides. It is a thing the Earth and the Sun produce together, continuously, out of motion and gravity, and it exists only as long as both keep doing their part. Remove the Sun's pull, or weaken it past the point where it can close the curve, and the orbit does not break the way a rail breaks. It simply stops being produced. The planet keeps moving. The curve was never there to break. It was only ever the shape that motion and gravity were drawing, together for as long as they agreed to draw it. The trajectory points wherever Earth happens to be pointing, the moment the system stops holding it. Different angles, different paths. The direction is essentially random. The galaxy is in every direction. Earth could exit pointing toward the galactic center, 50,000 light years away. It could exit pointing toward the outer rim. It could exit perpendicular to the disk, climbing out of the plane of the Milky Way into the thin galactic halo. The direction does not change the physics, only the scenery. At 30 kilometers per second, Earth covers about 3 light hours in a day, 1 astronomical unit in roughly 2 months. The orbit of Mars, which is half again as far from the Sun as Earth's, is reached within months. The crossing isn't a single event exactly, it is a steady, silent passing through. Earth is moving along a hyperbolic path, with the Sun's gravity slowing it slightly as it climbs out of the gravitational well. The slowing is not enough to bring it back, but it is enough to change the shape of the climb. The math says Earth's speed at infinity, the speed it would carry once the Sun's gravity stops mattering, is a few kilometers per second less than where it began. Earth slows from 30 to roughly 24 or 25 by the time it crosses the far edge of the Oort cloud. From there it doesn't slow much further, there is nothing left to pull it. 24 kilometers per second is still fast. That is more than 50,000 miles per hour. That is the speed of a planet on a permanent ballistic arc through interstellar space. If what we're sitting with tonight pulls you in, this channel runs deeper into material like this every week. Subscribe if you want to keep going, comments shape what gets explored next, then we keep moving. For comparison, Voyager 1, the only object humans have ever launched that has crossed into the interstellar medium, is moving at about 17 kilometers per second relative to the Sun. It has been travelling since the late 1970s. It crossed the heliopause, the bubble where the Sun's solar wind meets the surrounding interstellar gas, in 2012. Voyager is slower than the Earth in this scenario. The Earth, ejected, would catch up to where Voyager is now in a few decades, and then pass it. The Earth has been moving the whole time, every century, every minute. Voyager is just doing what every body in the galaxy does, except very slightly faster than most. There is a strange comfort in that fact briefly, and then the comfort goes. Because what the comparison reveals is that the velocity required to leave the Sun is not exotic. It is just the velocity a planet already has, in a different geometry. Take a planet's orbital speed and aim it outward instead of sideways, and the planet leaves. The escape was always inside the math. Look at the inner solar system from outside it. 8 planets, a few dwarf planets, a belt of rocks, 2 belts of comets and ice, all of them moving, each one carrying enough kinetic energy that, if the gravitational balance changed by the right amount, they would leave. The reason none of them have left is that the balance has held. The reason none of them will leave is that the balance is expected to hold for billions of years more. The reason a planet, somewhere, in some other star system, was ejected last week is that for that system, the balance didn't hold. The galaxy contains hundreds of billions of star systems. The galaxy also contains, near as anyone can measure, considerably more planets than stars. Multiply those numbers together, the number of planets that lose their balance in any given year across the disk of the Milky Way is not 0. It is not even small. Earth's path, drawn forward across the page, eventually leaves the borders of the solar system, not at a single moment. The borders are not sharp. The Kuiper belt fades into the inner Oort cloud, which fades into the outer Oort cloud, which fades into the interstellar medium itself. There is no fence. There is no event. There is just a region where, at some point, the gravity of the Sun stops being the dominant force on Earth's trajectory, and the gravity of the galaxy in aggregate takes over. By the time Earth has crossed the Oort cloud, the Sun is one bright star among many, brighter still than its neighbours, but no longer obvious. From the Earth's surface, if the surface were still hospitable to looking, the Sun in the sky would be like Sirius is from Earth now, only fainter, a bright point that would stand out in any constellation, but that you would not think of as a sun. The Sun, viewed from outside the solar system, is just another star. And there are already worlds out there waiting. There are more of them than there are stars. A single point of disturbance, somewhere in a survey field that contains hundreds of thousands of stars at once. For a few weeks, the light from one of those distant background stars grows brighter, then dimmer. The shape of the brightening is precise, mathematical. It is the signature of a gravitational lens, something passed in front of the star, close enough to bend the star's light around it, focusing the brightness toward the telescope for a brief, characteristic moment. The something is not a star. The shape of the brightness curve, fitted against the equations of general relativity, gives a mass. The mass is roughly the mass of Earth. The light shows no sign of a stellar companion, no host, no system, just a planet-sized object, moving alone through the disk of the galaxy, briefly passing between the telescope and a more distant sun. Ogu 2016 BLG 1928, detected in 2020 by a microlensing survey from the ground. Earth mass, no parent star detectable. A planet drifting. It is not the only one. PSO J318 5-22 was identified in 2013, about 80 light-years from the Sun, an object with the mass of a small gas giant, somewhere between 6 and 8 times the mass of Jupiter, no star anywhere near it, Y0855-0714, just over 7 light-years away, sits in the grey zone between large planet and small brown dwarf, drifting through the dark closer to the Sun than Proxima Centauri is to Alpha Centauri A, the closest known object of its kind, closer to Earth than the nearest star that anyone calls a star. Right now, as you're listening, Y0855 is out there, 7 light-years away, a cold, dark world drifting through interstellar space with no sun of its own. It was found not because it shines, because it barely does, but because its faint infrared glow and its motion across the sky gave it away to an instrument built to look for exactly this kind of warmth in the dark. It is one of the very few of its kind close enough and warm enough to detect at all. For every one like it that has been found, there are, by every estimate, vast numbers that have not, drifting in the same dark, too cold or too far or too unlucky in their geometry to ever announce themselves. The nearest of these dark worlds is closer than most of the stars in the night sky. It has been there the whole time, in a direction anyone could point to, and almost no one knows its name. The galaxy is full of these. How full is what the survey data, accumulating for decades, has started to make clear? Microlensing only works when the geometry is right. The lensing object has to pass directly between the telescope and the background star within a very tight angular tolerance. Most lensing events that could be detected never happen because the geometry isn't there. Most lensing events that do happen are missed because the telescope isn't looking. Most lensing events that are seen are stars or stellar remnants or substellar objects of various kinds, not isolated planets. But the planets show up. Year by year, the catalogue grows, and when surveys extrapolate from the detections they have, accounting for the geometry they missed and the events they didn't catch, the numbers that come back are enormous. Microlensing analyses now suggest there may be roughly 20 free floating planet mass objects in the galaxy for every star, possibly more. The estimates vary, the uncertainties are wide, but no analysis returns a number that is small. The galaxy contains around 200 billion stars. The number of rogue planets, by the current best estimates, may run into the trillions. The sky has more dark worlds in it than it has stars. It has always had more. It just hasn't, until recently, had anyone able to count. There is a comparison that helps. The ocean, the surface of Earth's ocean, the part where light reaches, where photosynthesis runs, where the visible animals live, is a thin film, 3% of the ocean's depth at most. The rest of it, the column that runs down from a few hundred meters below the surface to the abyssal plain 10,000 meters down, is dark, lightless. cold. Most of the biomass on Earth lives in that dark column. The surface is the minority. The dark is the rule. The galaxy is the same shape. The stars are the surface, the lit layer, the thin film where light is, where we see, where almost everything we know about the universe comes from. Below the surface, around the surface, between the surface, is the dark, and in the dark are the rogue worlds, drifting, numerous, mostly invisible, mostly not even named. A planet without a star has nothing to be lit by. It is dim by definition. It radiates its own faint heat, weak infrared from a body that has cooled to within a few degrees of the cosmic background. The only way to see one, almost always, is to catch it passing in front of something brighter, microlensing, briefly, statistically, by accident. The catalogue of confirmed rogue planets, as of the mid-2020s, runs to a few dozen named objects. The estimated population runs into the trillions. The ratio is one of the largest gaps between what is known and what exists in any field of modern astronomy. The dark population is real, it just isn't visible. Sit with the size of the gap for a moment. A few dozen detected, trillions estimated. That is not a small uncertainty around a known number. It is the difference between the handful of things that happen to reveal themselves and the vast population that physics says must be there. Every confirmed rogue planet was a piece of luck, an object that happened to drift across the line of sight to a distant star at the precise angle and moment a survey was watching. The geometry that makes such a detection possible is rare. The window during which it can be caught is brief, weeks at most. Miss the window, miss the planet, and it returns to being invisible, drifting on, never to betray itself the same way again. For every rogue planet ever detected, the surveys imply there are billions that cross no useful line of sight, that lend no background star, that no instrument was pointed at when their brief moment came. The detected ones are not a sample of the population. They are the few accidents the population happened to produce in front of an audience. Most of the known rogue planets are large. The ones that are easier to detect are gas giants, which produce stronger lensing signals because they are more massive. Smaller, terrestrial rogues, planets like Earth, are harder to find. The lensing signal from a terrestrial mass is brief and faint. Most of those events go undetected by current ground-based surveys, which is one reason the space-based Roman telescope, scheduled for the late 2020s, is expected to multiply the known catalogue of small rogues by orders of magnitude. The data is going to expand. The dark, partially, will become visible, briefly, statistically, by accident. The Earth, in this scenario, is going to join this population. Not as an outlier, not as a curiosity, as one more member of the majority. The Earth, ejected, becomes one of the trillions, indistinguishable from the others, drifting, dim, dark. If a microlensing survey in some other epoch ever catches the Earth in the act of crossing in front of a distant star, the signal it produces will be the same brief brightening, the same characteristic curve that the surveys are catching now from objects that already exist out there. Earth mass, no host, drifting. The survey will not know which planet it is. The survey will note the detection. The survey will move on. The Earth will continue. There is something about scale that does not register without an anchor. 20 rogue planets for every star. 200 billion stars in the galaxy. The math is simple. The number that comes out of it is not. It says that, within any 1 cubic light year of the galaxy's disk, there is on average somewhere between 0 and a few rogue planets. None of them visible, none of them from where Earth currently sits, even nameable. The cubic light year just to the right of you, in galactic terms, has statistically something in it that is the size of a planet drifting silently that no telescope on Earth will ever see. The same is true of the cubic light year just to the left, and the one above, and the one below, and the next 10,000 in any direction. The galaxy is mostly dark worlds. We just don't have the eyes to see them. A field in midsummer. The grass is high. Wildflowers, dust in the air, the steady drone of insects in the long light of an afternoon that should not be different from any other afternoon. It is noon. The sky is clear and snow is falling on the wildflowers. The flakes are small. Not many at first. They land on the leaves, settle on the soil, melt almost immediately because the ground is still warm, but the snow is real. The temperature, somewhere above the field, has crossed the line. It has not crossed back. 2 weeks have passed since the orbit broke. Pandas panda farce. The first thing the surface notices is the light. The sun is smaller every morning, a few percent smaller a day at the beginning. The change is subtle enough that no animal registers it. A human, looking up casually, would notice nothing wrong. A human watching the sun's disk through a filter, day by day, would catch the shrinking. Most humans, not watching, do not. But the energy budget of a planet is set by the size of its sun in the sky. Earth, at 1 astronomical unit, receives about 1,360 watts of sunlight per square meter at the top of its atmosphere. At 2 astronomical units, that number drops by a factor of 4, at 3 by a factor of 9. The relationship is inverse square. The further Earth moves, the less light it gets, and the curve falls steeply at first. By the time Earth has reached the orbit of Mars, less than 3 months out, the sunlight reaching the planet has dropped by more than half. 3 months after that, around the asteroid belt, the sun delivers less than 10% of what it once did. The surface, which had been heated by a continuous bath of solar radiation for 4.5 billion years, is no longer receiving it. The atmosphere buffers briefly. The oceans buffer longer. The oceans, holding enormous thermal mass, an amount of stored heat equivalent to thousands of years of solar input, do not give it up quickly. The atmosphere, sitting on top of the warm sea, stays warmer than it would otherwise. The surface cools, but slowly. Within a week, the global average surface temperature has fallen to roughly -50 degrees Celsius. Within a year, it approaches -100. The oceans, still liquid, are the only reason it doesn't fall further faster. The water, in giving up its heat to the air above it, is converting the atmosphere into a thermal reservoir that the cooling can no longer easily push past. The surface is freezing, the air is freezing, the water is not freezing through, not yet, because the water has too much heat to give. But the heat is leaving. A planet's average temperature is set by the balance of energy in and energy out. With the sun receding, the energy in falls, the energy out, the slow infrared radiation from every warm surface on Earth into the dark of space, continues at the rate it always did. The math is one-sided. Earth radiates more than it absorbs. The deficit accumulates. The surface cools. The cooling is not even. The poles, which were already cold, freeze fastest. The polar caps spread south and north. Ice that took centuries to recede during interglacial periods now grows back over weeks. The lakes freeze. The rivers freeze. The forests, in the second week, start to die from the cold first, and from the dark second, because the temperature crosses the limit of what living tissue can survive before the absence of light has finished doing its slower work. The slower work is the food web. Photosynthesis is what every part of the biosphere that depends on sunlight runs on. Plants on land, algae in the sea, cyanobacteria in everything. They take in carbon dioxide and water, and using the energy of sunlight, they make sugar. The sugar feeds them. The sugar also eventually feeds everything that eats them. The food web on Earth's surface is a pyramid with photosynthesis at the base. Take photosynthesis out and the pyramid collapses from the bottom. It collapses fast. A few weeks after the sun has dropped to 10% of its prior brightness, photosynthesis on Earth has effectively stopped. The plants are starving. They are also freezing. By the end of the first month, most of the temperate vegetation has died. Tropical vegetation, which has more thermal mass and is sitting in regions that were warmer to begin with, lasts a little longer. Not much longer. By the second month, almost nothing green is photosynthesizing anywhere on the surface. The herbivores die next. The animals that ate the plants run out of food within weeks. The carnivores that ate the herbivores last a little longer, but not much. Within a few months of the sun's brightness falling below the threshold required for photosynthesis, the surface food web has collapsed at every trophic level. The bodies are still there. The cold preserves them. The microbial life in the soil, which had run on the slow decomposition of organic material, slows, then slows more. Microbial activity for many soil species depends on temperature. Below freezing, most surface decomposers go dormant. The corpses do not rot. The dead leaves do not break down. The forests stand, frozen, as they were the day the temperature crossed the line. Some of them will still be standing in the dim of a permanent night, 10,000 years later. The cold preserves them. There is no decay. The whole surface becomes a kind of held still photograph. On a living Earth, death is constant and so is renewal. The dead broken down and returned to the soil and taken up again by the next generation of the living. The whole cycle turning so steadily that nothing stays as it was for long. The cold stops the cycle at both ends. Nothing new grows because there is no light and no warmth to grow it. And nothing old decays because the decomposers that would break it down are frozen into dormancy. So the surface freezes in place, mid-scene, exactly as it was in the last weeks before the cold one. A bird caught on a branch, a half-eaten leaf, a footprint in what was mud and is now permafrost harder than stone. The surface of the planet becomes a record of its own final living moment, preserved by the cold that ended it, held unchanged for as long as the cold lasts, which is to say for longer than there will ever be anyone to read it. A forest somewhere temperate, midsummer. The light is noticeably weaker, the air noticeably colder, but the day is not yet catastrophic. Birds are still flying, the deer are still grazing, slowly, because the grass is harder to find than it was last week. The migration patterns that triggered this morning still triggered, because the day length is what triggers them, and the day length in the first weeks has not changed. Nothing in the natural world has the cognitive architecture to register what has happened. The instinctive behaviours continue, the reproductive cycles still run. A robin builds a nest. The nest will be there for years, nothing will hatch in it. The animals are not aware of the change. They are aware of the cold, they are aware of the hunger, but they are not aware that the sun is leaving, because no animal has ever needed that information. The sun has always been there. The animals' clocks are calibrated against the sun's daily presence and the sun's seasonal angle. They are not calibrated against the sun's distance. There was never a reason to be. A herd of deer moves across a hillside. The leader, an older doe, is leading the herd toward a meadow it has used every August for 10 years. The meadow is still there, the grass in it is still there. The grass is also frozen, dusted with the first true snowfall of a season that should not have started yet. The herd stops at the edge of the field. The deer paw at the snow. They find frozen grass underneath. They lower their heads and chew. In a forest a few miles away, an old oak's leaves have not turned. The leaves froze before they could begin the photosynthetic shutdown that normally precedes autumn. They are still green. They are dead. Nothing looks up. That is the thing in this first month that catches the listener. The world has begun ending, and the world doesn't know. It continues to do what the world has always done. The birds fly south because their internal clocks say to, even though the south no longer offers what it used to. The whales sing. The bees, what remains of them in this cold, return to their hives. The herd moves. The leaves do not turn. everything goes on the way it has always gone on. Everything will keep going on until the last energy in the last warm pocket is gone. The vignette ends not with a death but with a silence. The animals don't look up. They never did. The thermometer continues to fall. By the third month, the average surface temperature is around -90. By the sixth month, it is past -100. The oceans are still liquid at the surface in some places, especially the deep oceans where convection brings warm water up. But ice is growing across the high latitudes and creeping toward the equator. The Arctic, which was already mostly ice, becomes solid. The Antarctic continent, already buried under 3 kilometers of glacier, becomes even more so, the ice extending outward over the surrounding sea. In the temperate latitudes, what had been ocean turns first to slush, then to a moving raft of sea ice that thickens by the week. By the end of the first year, much of the surface ocean is locked under ice. The ice itself is an insulator. Once a layer forms, it slows the cooling of the water below. The deeper ocean, with its enormous thermal mass, takes much longer to give up its heat. The surface freezes, the deep does not yet. The boundary moves slowly downward, year by year, decade by decade. Centuries from now, the ice will be thick. Millennia from now, thicker. The deep ocean, though, will still be liquid. We will get to why. The number that sets the pace of all of this is the heat capacity of water. Water holds heat better than almost anything else on the planet's surface, and the oceans hold an amount of it that is difficult to state in any way that lands. The world ocean stores roughly 1,000 times more heat than the entire atmosphere above it. It absorbed that heat slowly across the ages from a sun that warmed it a little every day. When the sun goes, the ocean does not give that heat back quickly. It releases it grudgingly through the surface into the freezing air, the way a stone wall that baked all afternoon goes on radiating warmth long into the night. That slow release is what stretches the surface cooling from the catastrophe the imagination expects into the staged, drawn-out process that actually unfolds. The air freezes in a week, the surface seals in a year, but the ocean, the great reservoir, takes centuries to surrender what it holds, and for those centuries it keeps the deep from freezing and slows the surface on its way to the deepest cold. The ocean is the reason there is a long after at all, rather than a quick and total end. The atmosphere itself is changing. Air is a gas only because the temperature is high enough to keep it one. Drop the temperature past a threshold, and gas becomes liquid. Drop it further, and liquid becomes solid. Air is no exception. Air is mostly nitrogen and oxygen, with traces of argon and carbon dioxide and water vapor. Each of these has its own condensation and freezing temperatures. Each of them, as the surface cools, eventually crosses those thresholds. The water vapor goes first. It was already condensing into clouds and falling as rain or snow. Once the surface freezes, the water cycle, the slow loop that drove most of the planet's weather, slows and then stops. The clouds don't dissipate, they just stop forming, because the seas are no longer evaporating, because the seas are sealed under ice. The sky, which had been crowded with weather for as long as Earth has had an ocean, starts to clear. The carbon dioxide goes next. At around -78 degrees Celsius, carbon dioxide deposits directly from gas to solid, skipping the liquid phase. Across the surface, in the second year, in the temperate latitudes that have cooled to that point, carbon dioxide begins to fall out of the air as fine white frost. On Mars, this happens every winter on the polar caps. On Earth, after ejection, it begins to happen everywhere. The frost accumulates. The atmosphere loses a part of itself, settling onto the ground. Then comes the next stage. Oxygen liquefies at 90.2 Kelvin, which is about -183 degrees Celsius. Nitrogen liquefies at 77 Kelvin, about -196. The surface, in its first century after ejection, has not yet reached those temperatures. The atmosphere, still mostly intact, is still mostly gas. The sky, by now, is no longer blue. It is a cold, glassy purple, thinning as carbon dioxide and water vapor continue to fall out. But oxygen and nitrogen still hold. They are still air. They still move when something disturbs them. A wind blows across a snowfield. The wind is the last thing on Earth that still moves the way it always did. It is also one of the last things that will. The air, in the centuries to come, behaves like a liquid that has cooled past its boundary. It thickens, it slows, it does not quite know it is about to become something else. Then it falls. The sun is no longer the largest object in the sky. It is the brightest by a wide margin, but it is also a point. Sirius from Earth's current orbit looks dimmer than the sun does from Pluto. The sun has receded that far. The sun is no longer obviously a sun. It is one bright star, more brilliant than the others, but not, to a casual glance, recognizable as the body that gave the planet its name and its climate and its history. A traveler at the equator, looking up at noon, would see a star slightly too bright to ignore in a sky that no longer has a day. There is no day. The sky is night. The night is permanent. And then the sky starts to come down. In the low places of the world, something is pooling. It is clear, faintly blue, very still. It gathers in the bottoms of valleys, in the deep basins where the old lakes used to be, in the craters and the canyon floors. It is liquid. It is not water. The water froze solid long ago, 2 miles down in some places, sealed under everything. This is something thinner, colder, that has only just now found a temperature low enough to exist as a liquid on the surface of a planet. It is oxygen. Liquid oxygen, pale and clear, pooling in the cold. The sky is falling, not metaphorically. The air, the actual atmosphere, the gas that every breathing thing on Earth ever depended on, is precipitating out of the sky and accumulating on the ground. This is the part of the story that the imagination almost never reaches. The cold, people can picture. The dark, people can picture. The freezing of the oceans, the death of the forests, those follow from intuition. But the loss of the sky itself, the conversion of the atmosphere from a gas into a layer of solid material lying on the surface, is something the imagination does not naturally arrive at. The atmosphere feels permanent. It is not. It is gas held in place by a temperature window. Close the window, and the gas has nowhere to be except down. Earth's atmosphere weighs about 5 quadrillion tons, 5 times 10 to the 18th kilograms of gas, held above the surface by nothing but its own warmth and the planet's gravity. The gravity never changes, the warmth does. As the surface temperature falls through the condensation points of each component gas, that gas changes state and comes down. Carbon dioxide was first, the frost that began falling in the second year. Then, over centuries, as the deep ocean's heat finally bleeds away, and the surface temperature creeps down through the coldest thresholds, oxygen and nitrogen follow. Think about what that means for the weather. Weather is the atmosphere in motion, air heated unevenly by the sun, rising where it is warm, sinking where it is cool, the whole vast circulation of the planet driven by the difference between the equator and the poles, between the day side and the night side, between the warm ocean and the cold land. Every storm that ever crossed the earth, every front, every hurricane, every gentle afternoon breeze, was the atmosphere redistributing solar heat. Take the sun away, and the engine that drove the weather stops. The temperature differences flatten. The air, no longer heated unevenly, no longer has a reason to move. The great circulation slows and stalls and stops. The last storm on Earth blows itself out and is never replaced. The wind dies, not because the air is gone yet, but because nothing is left to stir it. For a while there is air, and it is still, the way the surface of a sealed jar is still. Then the air begins to fall, and even the stillness ends. The water cycle was the first of the planet's great loops to break. For as long as Earth has had oceans, water has evaporated from the sea, risen as vapor, condensed into clouds, fallen as rain, and run back to the sea. The loop turned every day, everywhere, for billions of years. It carved the canyons and fed the rivers and watered every living thing on land. When the surface freezes and the oceans seal under ice, the loop stops at its source. No evaporation, no clouds, no rain. The sky, which had been crowded with weather for the entire history of complex life, clears for the last time and stays clear. The clouds do not blow away. They simply stop being made. The last cloud on Earth thins into nothing, and no cloud takes its place. Oxygen liquefies at 90.2 Kelvin and freezes solid at 54.4. Nitrogen, which makes up 78% of the air, liquefies at 77 Kelvin and freezes at 63. The surface, given enough time after the ocean's thermal reservoir is finally exhausted, crosses each of these lines in turn. The crossing takes centuries because the ocean fights it the whole way, giving up its heat grudgingly through the thickening ice. But the ocean is finite. The radiation into space is relentless. The lines get crossed. First, the oxygen condenses. It falls as a fine cold rain, then pools in the low places, the pale blue liquid in the valley bottoms. As the temperature continues down, the pooled oxygen freezes. Then the nitrogen, the bulk of the air, reaches its own condensation point. It falls. There is so much of it that it does not merely pool, it accumulates, it builds. Nitrogen snow, drifting down through a windless dark, settling against the frozen mountains and filling the basins and burying the frozen forests that have been standing, preserved, since the first month. The order matters, and the order is set by chemistry. Each gas has its own temperature at which it can no longer remain a gas, and the surface crosses those temperatures in sequence as it cools. Water vapor and carbon dioxide go early, at temperatures the surface reaches within years. Oxygen waits for 90 Kelvin, nitrogen for 77, and the surface takes centuries to fall that far because the ocean below keeps feeding heat upward through the thickening ice. So the atmosphere does not come down all at once. It comes down in layers, sorted by the physics of each gas, the heaviest and most easily frozen settling first, the lighter and colder holding out longest. The argon, a small fraction of the air, freezes between the oxygen and the nitrogen. The last traces, the noble gases that resist becoming solid until the very coldest temperatures, are the final whisper of atmosphere to leave the sky. By the time they go, there is almost nothing left above the surface but the hard vacuum of interstellar space. The sky becomes the ground. Think of a roof. Not a roof that collapses all at once, with a crash and a cloud of dust. A roof that folds inward slowly, one layer at a time. The outer shingles come down first, the lightest material, settling onto the floor, then the next layer, then the next, until the roof, which had been overhead, is lying flat across the floor of the house, and there is no longer any difference between the ceiling and the ground. The house has no inside anymore. It is all one surface. That is the atmosphere, settling. Carbon dioxide frost, then liquid and frozen oxygen, then nitrogen snow, layer over layer, until the gas that had been the sky is lying meters thick across the surface of the planet. The 5 quadrillion tons of air becomes a blanket of solid and liquid material, deepest in the basins, thin on the high ground, but everywhere, covering everything. The sky, which had been a thing you looked up into, is now a thing you stand on. What remains above is almost nothing. A trace of residual gas, the last components that haven't quite reached their condensation point, a whisper of an atmosphere far thinner than the air on Mars. The pressure at the surface, which had been one full atmosphere, the weight of the whole column of air pressing down, drops toward vacuum. The planet, which had worn a thick coat of gas for billions of years, takes it off and lies down in it. Several centuries in, the surface has cooled past 90 Kelvin. Liquid oxygen pools in the valleys, clear and faintly blue, perfectly still because there is no wind to disturb it. The wind requires air. The air is on the ground. Drifts of nitrogen snow have built against the mountain ranges and filled the old craters. Soft white accumulations meters deep, untouched, unmelting. The sky, which had been thinning steadily for centuries, is now mostly absent. If you stood on the surface, in a suit that could keep you alive in temperatures that would freeze your blood to glass in seconds, and you looked up, the stars would not twinkle. Stars twinkle because their light passes through a moving atmosphere, and the atmosphere bends and shifts the light on its way down. With almost no atmosphere left, there is almost nothing to bend the light. The stars burn steady, cold, hard points, uncountable, fixed. They do not waver, they do not move. They are simply there, all of them, all at once, in a black sky that no longer has a horizon line of air to soften its edge. The silence is total, not the silence of a quiet night, which is full of small sounds, wind and insects and the distant movement of things. This is the silence of vacuum. Sound is a wave that travels through a medium. The medium is gone, lying frozen on the ground. There is nothing left to carry a sound. A rockfall in the distance would make no noise at all. The loudest event imaginable on this surface would be perfectly, permanently silent. The wind has stopped. There is no longer any wind because there is no longer any air. Standing on the frozen nitrogen, looking up, you could find the sun if you knew exactly where to look. It is one bright dot among thousands. From the surface, looking up through what little atmosphere remains, it would not catch the eye. It does not announce itself. It is brighter than its neighbours marginally, but the sky is so full of stars that the marginal brightness disappears into the crowd. A person who had never been told which dot was the sun would never pick it out. A person who had been told would have to work to find it. The star that gave this planet everything is now indistinguishable at a glance from the background. This is the moment in the long after when Earth stops looking anything like Earth from the outside. No blue, no white swirl of cloud, no green, no oceans visible, because the oceans are sealed under ice and the ice is buried under frozen air. From space, the planet is a featureless ball, grey-white, the colour of frozen nitrogen and carbon dioxide, and the ice beneath reflecting almost nothing, because there is almost no light to reflect. An astronomer in another system, scanning this region of space, would have no way to know that this object had ever been anything other than a dead rogue. The atmosphere that would have hinted at its history is on the ground. The water that would have suggested a past is frozen and hidden. The surface tells no story. The surface is blank. And yet the surface is not the planet. The surface is the lid. The story of the imagination, the story of total death, ends here, with the blank ball and the buried air and the silence. That story is wrong. It mistakes the lid for the contents. It mistakes the surface which has died for the planet which has not. Above the frozen atmosphere, the dark. Below it, sealed away from the cold, from the silence, from the absence of the sun, something the surface story never looks for. Under the sky snow, the oceans are still moving. Past recedes. Go down. Through the layer of frozen nitrogen. Through the carbon dioxide frost beneath it. Through the buried, preserved forests, still standing, their leaves still green where they froze. Through the surface that was once soil, now permafrost harder than concrete. Down to the top of the ice. The ice is water ice now. The real ocean, frozen from the top down across the centuries. The cap is thick, in places 2 miles thick. It is dark because no light reaches here, and no light has reached here for a very long time. It is also not the bottom. Keep going, down through the ice, 2 miles of it, until the ice ends. Below the ice, water, black water, moving slowly. Liquid, not frozen, The deep ocean of the Earth, sealed beneath a cap of ice miles thick, still liquid, still flowing, still warm enough at the bottom to stay a sea. This is the part of the story that overturns the rest. The assumption that runs underneath every imagining of this scenario is simple. No sun, no life. The sun is the source. The sun is the engine. Take the sun away and everything that the sun powered dies, because everything alive was in the end running on sunlight. The assumption is intuitive. It is also, for the deepest and oldest part of the biosphere, false. Life on Earth did not begin in the sunlight. The leading account of where life started does not put its origin in a warm sunlit pool at all. It puts it at the bottom of the sea, at hydrothermal vents, in the dark, where mineral-rich water heated by the planet's interior met the cold seawater and produced steep chemical gradients across mineral surfaces. The energy that drove the first metabolisms did not come from a star 93 million miles away. It came from the chemistry of the rock and the heat of the planet's own interior. The sunlight half of the biosphere, the photosynthesis, the surface food web, the green and growing world came later. It was an addition, it was not the foundation. The foundation is still down here, in the dark, where it started. A hydrothermal vent is a place where the planet's internal heat reaches the ocean floor. Seawater seeps down through cracks in the crust, gets heated by the hot rock below, dissolves minerals and metals from the rock, and rises back up, superheated, laden with chemistry. When it hits the cold seawater of the deep ocean, the dissolved minerals precipitate out, building chimneys of rock that rise from the sea floor. Black smokers, where the water is hottest and darkest with iron sulfides. White smokers, cooler, paler. The water coming out can be hundreds of degrees, kept from boiling by the immense pressure of the ocean above. Around these vents in the present-day Earth, ecosystems run with no input from the sun at all. The base of the food web at a hydrothermal vent is not a plant, it is bacteria and archaea that perform chemosynthesis, pulling energy out of the chemical compounds the vent emits. Hydrogen sulfide, methane, hydrogen. The microbes oxidize these compounds and use the energy to build the organic molecules that everything else feeds on. On top of the microbes sit the tube worms, which have no mouths and no guts, hosting colonies of chemosynthetic bacteria inside their bodies and living off what the bacteria produce. Clams, shrimp, crabs, whole communities, dense and thriving, in total darkness, under crushing pressure, fed entirely by the chemistry of the planet's interior. None of it needs the sun, none of it ever did. These ecosystems were independent of sunlight from the beginning. They were running before there was an oxygen atmosphere. They were running before there was anything green. When the sun is lost, they do not notice because the sun was never part of how they worked. The vent keeps venting, the chemistry keeps flowing, the microbes keep building, the food web keeps turning over. The energy that drives all of it comes from below, from the heat of the Earth itself, and that heat does not depend on the sun and never has. And the vents are not the whole of it. Below the seafloor, down in the rock itself, in the pores and cracks of the crust kilometers beneath the ocean, there is more life, a vast hidden biosphere of microbes living in the stone. They metabolize slowly, some of them so slowly that a single cell may divide once in 1,000 years, feeding on the chemistry of the rock and the trickle of energy from the planet's interior. This deep biosphere, the life inside the Earth's crust, is estimated to hold somewhere between 15 and 23% of all the biomass on the planet. Nearly a fifth of everything alive on Earth lives in the dark, in the rock, fed by chemistry, untouched by sunlight, indifferent to the sky. When the surface freezes and the sun disappears, this enormous buried population does not feel it. It was already living the way an ejected planet would require everything to live. It was already in the dark. The surface biosphere, the green and breathing world, was always the newer, more fragile layer. It was the part that needed the sun, the part that grew fast and bright and complex on the energy pouring down from the sky, and the part that dies first and most completely when the sky goes dark. The deep biosphere is older, slower, and tougher. It was here first. It was here before there was an atmosphere worth breathing, and it would be here after, in the sealed dark sea and the cracked deep rock, running on the same internal heat it always ran on, for as long as that heat lasts. There is a comparison for what the planet has become, and it is not a comparison to anything dead. It is a comparison to a place that is, right now, one of the leading candidates for life beyond Earth. Europa, the fourth largest moon of Jupiter. From the outside, a ball of ice, cracked and refrozen and cracked again, with a surface temperature far below anything on the Earth's surface even now. A dead-looking world, a frozen shell, and beneath the shell, an ocean, a global ocean of liquid water, 15 to 25 kilometers below the surface ice, perhaps 100 kilometers deep, containing more than twice as much water as all of Earth's oceans combined. Kept liquid not by the sun, which at Jupiter's distance delivers a fraction of the warmth that reaches Earth, but by the heat of Europa's interior, flexed and warmed by the gravitational pull of Jupiter and by the slow decay of radioactive elements in its rock. Europa has had that ocean beneath that ice for billions of years, without ever having a sun nearby that mattered. Right now, beneath the ice of Europa, the same kind of ocean Earth would become already exists, has existed. The chemistry that could support life, the rock and the water and the heat, all of it present, all of it active, all of it sealed beneath a frozen lid, the way an ejected Earth would be sealed beneath its own. An ejected Earth becomes a larger, warmer Europa, a planet with a dead, frozen, blank surface, and a deep, dark, chemically active sea underneath. The difference is one of scale. Earth is bigger, Earth has more internal heat. Earth's ocean was full of life when the freeze began, life that had spent billions of years learning to live without the sun in exactly the places where the sun never reached. Europa might have started life on its own, in the dark, the way Earth's deep biosphere started. We don't know. An ejected Earth would not have to start, it would simply continue. A pot on a low flame. The heat comes from below, not from above. Turn off every light in the kitchen, close the windows, let the room go dark and cold, and the pot on the low flame keeps simmering, because the flame underneath does not care about the room. The surface of the water might develop a skin, the top might cool, but the bottom keeps moving, because the heat is coming from where it always came from, underneath, indifferent to everything happening above. The Earth, ejected, is a pot on a low flame. The flame is the planet's interior. The skin on top is the ice, 2 miles of it, sealing in the heat. And the simmer at the bottom, the slow convection of a deep ocean warmed from below, continues, in the dark, the way it always did at the vents, the way it did before the sun ever mattered to anything alive. 10,000 years after ejection, Earth is somewhere in interstellar space now, no longer near any star, drifting through the dark between the lights. The surface is sealed under 2 miles of ice, water ice below, atmosphere ice above, layered and silent and blank. The sun, if you went up to the surface and looked, could not be found at all without instruments. It is gone from the sky in every way that matters. At the bottom of what was once the Atlantic Ocean, a hydrothermal vent rises off the seafloor. Black smoke curls up from its chimney into water that has not seen light in geological time. Water that has never seen light, because this water is 2 miles down and was never lit even when the sun was at full strength overhead. The vent emits its chemistry the way it has for as long as it has existed. A microbial mat coats the rock around the base, thick and slow and alive. Tube worms, or whatever the tube worms have slowly become across 10,000 years of evolution in a sealed dark sea, sway slightly in the current that the vent's heat generates. The crabs move across the rock, the clams filter the water, the food web turns over, microbe to worm to predator, energy flowing from the planet's hot heart up into the bodies of things that have never needed anything else. The chemistry runs, the energy flows, the mat grows, the worms feed. Nothing here registers that anything has changed, because nothing here ever depended on the thing that changed. The sun has been gone for 10,000 years. The vent has not noticed. That is the whole of it in 2 sentences. Everything the cold open set up, the loss, the dark, the cooling, the slow conversion of a living planet into a blank ball drifting in the night, all of it true, all of it real, all of it happening exactly as described, and underneath all of it, at the bottom, in the place where life actually began, none of it matters. The horror is not that the biosphere died. The horror is that a part of the biosphere, the oldest part, the original part, continued and never knew there had been anything to survive. The tube worms do not look up. They never did. They have no eyes for up. There is no up, down here, that ever held anything they needed. The sun, 93 million miles away when it was there, was always irrelevant to them. And its absence is equally irrelevant, and the same slow current that fed them 10,000 years ago feeds them now, warmed by the same heat, flowing past the same rock. The deer on the hillside, in the first weeks, did not look up. The worms at the vent 10,000 years later do not look up either. The biosphere that survives was never paying attention to the sky. It was looking down, at the rock, at the heat, at the chemistry, the whole time. That is the quiet center of the whole story. The part of life that the sun built, the bright surface world, was always the part that could be lost, because it was always the part that depended on something outside itself. The part of life that built itself, down in the dark, on the planet's own heat, was never at risk from the sky at all. When the sun is taken, the dependent part dies and the independent part continues, and the continuing part does not mourn, does not register, does not so much as pause. It goes on doing what it did before there was a surface worth living on. What it will go on doing after the surface is a frozen record of a vanished world, indifferent, ancient, and alive. There is one thing we have not said yet. The question that everything so far has been quietly approaching. Because the journey does end. Eventually, just not in any of the ways the imagination expects. We'll get there. Go down further. Past the vent, past the seafloor, into the rock itself, down through the crust, thin where the ocean sat on it, thicker under the old continents, down into the mantle, the vast, slow region of hot rock that makes up most of the planet's volume. Rock that flows over millions of years like something between a solid and a liquid, down through nearly 3,000 kilometers of it, to the core. The center of the Earth. Solid iron crushed by the weight of everything above it into a sphere denser than anything on the surface, at a pressure of more than 3.5 million times the atmosphere that used to sit on top of the planet. Around that solid inner core, liquid iron churning, a sea of molten metal the size of Mars, moving in slow, vast currents driven by heat escaping from below. The temperature here is about 5,200 degrees Celsius. That is hotter than the surface of the sun, the photosphere of the sun, the glowing surface that lit the Earth for 4.5 billion years, sits at around 5,500 degrees. The center of the Earth is nearly as hot as the outside of a star, and it is sitting there right now, beneath 6,000 kilometers of rock, beneath the dead frozen surface, beneath the buried air, radiating its heat slowly upward, the way it has since the planet formed. The sun went out, from the planet's point of view, 10,000 years ago. The core has not begun to notice. The reader has been told the surface dies. That part follows from intuition. Then the reader was told the deep ocean does not die, that the vents keep running, that the oldest part of the biosphere continues, and that was a surprise because it overturns the assumption that life needs the sun. Now the bigger surprise. The reason the deep ocean stays liquid, the reason the vents keep venting, The reason any of it is possible is that the planet has a furnace inside it that operates on a timescale measured not in centuries, not in millennia, but in billions of years. And that furnace owes the sun nothing. Earth's heat does not come from the sun. The sun warmed the surface, set the climate, drove the weather, powered the photosynthesis, but the heat inside the planet, the heat that drives the vents and keeps the core molten and moves the continents and generates the magnetic field, comes from somewhere else entirely. It comes from two sources, and neither of them is the sun. The first source is primordial. When the Earth formed 4.5 billion years ago, it formed by accretion, countless smaller bodies colliding and merging under their own gravity, each collision converting motion into heat. The young Earth was molten, a ball of magma, glowing. Over the eons since, it has been cooling, slowly, releasing that original heat of formation into space. But it is a big planet, and rock is a poor conductor, and the heat at the center has a very long way to travel to escape. Some of the heat in the core today is the leftover warmth of the planet's own birth, still working its way out 4.5 billion years later. The planet is still cooling from the day it was made. The second source is stranger, and it is the one that matters most for the long after. It is radioactivity. Scattered through the mantle and crust are atoms of uranium, thorium and potassium, specifically uranium-238, thorium-232 and potassium-40. These are unstable, slowly, atom by atom, across timescales of hundreds of millions to billions of years, they decay, and each decay releases a small amount of energy as heat. There are a lot of these atoms, spread through the enormous volume of the Earth's interior. Their decay produces a continuous, planet-wide output of heat that does not depend on anything external. It does not need the sun, it does not need an atmosphere, it does not need a surface that is alive. It just needs the atoms, and the atoms are there, decaying, the way they have been since the planet gathered them in from the cloud of debris that formed the solar system. Right now, beneath the surface you're standing on, half the heat coming up from the planet's interior is uranium and thorium and potassium decaying. It has been doing that for the entire history of the planet. It has barely started. The total heat flowing out of the Earth, summed over the whole surface, is about 47 terawatts. For comparison, all of human civilization's energy consumption is around 20 terawatts. The Earth's internal heat output is more than twice everything every human machine produces, and it flows continuously from the planet's interior into space, whether anyone is there to use it or not. Roughly half of that 47 terawatts is radiogenic, generated by the decay of those unstable atoms. The other half is the primordial heat, the leftover warmth of formation, still leaking out. The sun's loss does not change this number. 47 terawatts before ejection, 47 terawatts 10,000 years after, 47 terawatts a million years after. The number declines, but it declines on the timescale of radioactive half-lives, which for these isotopes run from about 700 million years for one isotope of uranium to 14 billion years for thorium. The heat does not switch off when the sun does. The heat does not even slow down in any way a human timescale could measure. The planet's furnace runs on its own fuel, fuel that was loaded at formation, fuel that pays out slowly across the deepest stretches of time. The comparison is to an inheritance held in trust. Not the kind that is spent and gone, the kind that is so large that only the interest is ever touched, and the interest alone is enough to live on indefinitely. The principle is the radioactive elements scattered through the mantle, an enormous reserve of stored energy. The interest is the slow trickle of heat their decay releases, year after year, age after age. The trust does not run dry in a century, or a millennium, or a million years. It pays out fractionally, steadily, across geological time, and the deep ocean lives on the interest. The planet inherited a fortune at birth, and has been spending it so slowly that billions of years in, most of it is still there. 1 million years after ejection. The core. Solid iron at 5,200 degrees, under pressure that would crush anything else in the universe down to a fraction of its size. Around it, the liquid outer core, churning, the slow, vast convection of molten metal, driven by the heat trying to escape from below. That motion does something beyond keeping the planet warm. Moving liquid iron is a moving electrical conductor, and a moving electrical conductor generates a magnetic field. The convection of the outer core is a dynamo, and it has been generating the Earth's magnetic field for at least 3.5 billion years. The field reaches out beyond the surface, beyond the atmosphere, far out into space, a vast invisible structure shaped by the planet's spin and the churning of its core. On the present-day Earth, that field deflects the solar wind, the stream of charged particles the sun constantly throws off, and protects the surface and the atmosphere from being stripped away. This is not a small or delicate thing. The magnetic field of the Earth extends tens of thousands of kilometers into space on the side facing the sun and streams out into a long tail on the far side, a structure larger than the planet itself by many times. It is generated entirely from within by the heat of the core driving the iron to convect, by the planet's rotation organizing that convection into a coherent flow. Nothing about it requires the sun. The sun is what the field protects against, not what powers it. Mars, which is smaller and cooled faster and lost most of its internal heat long ago, lost its global magnetic field billions of years ago, and with it lost the protection that might have kept its atmosphere from being stripped away into space. Earth, larger and hotter and still churning, kept its field. An ejected Earth would keep it still, for as long as the core kept moving, which is to say for a very long time. After ejection, there is no solar wind to deflect, but there is still cosmic radiation, the high-energy particles that come from everywhere, from supernovae and distant violent events across the galaxy, sleeting through interstellar space in every direction. The magnetic field, generated by the still churning core, still deflects them. The deep ocean, sealed under 2 miles of ice, shielded by a magnetic field generated by a furnace that does not know the sun is gone, sits protected, the way it always was, from radiation that might otherwise reach it. The field is weaker than it once was, perhaps, slowly diminishing as the core very gradually cools across billions of years. But it is present. The planet keeps its shield because the planet keeps its heart, and the heart runs on fuel the sun never supplied. The interior has barely begun to notice the change. From the perspective of the core, the loss of the sun is a surface event, a change in the temperature of the outermost skin of the planet, irrelevant to the immense hot machine grinding away 6,000 kilometers down. The continents, if anything still moved them, would keep moving. The mantle keeps convecting. The plates, locked now under a frozen surface, still ride on rock that flows. The planet's geology continues. The heat keeps rising. The magnetic field keeps turning. The Earth, by every internal measure, is still a living planet, geologically active, magnetically shielded, internally hot, doing everything it did before, except radiating its warmth into a sky that no longer has a sun in it. This is the fact that reframes everything that came before. Earth's internal heat does not depend on the sun. If the sun went out tonight, the planet beneath you would still be radiating warmth into space billions of years from now. The deep ocean would stay liquid for hundreds of millions to billions of years. The vents would keep running for that whole span. The magnetic field would keep turning. The deep biosphere, sealed and shielded and fed by chemistry, would have in principle a window of survival measured in a meaningful fraction of the age of the universe itself. The surface dies in years. The deep ocean survives for an eon. The difference between those two timescales is the difference between what the sun gave the Earth and what the Earth gave itself. The sun gave the surface, the Earth gave the deep, and when the sun is taken away, the surface is what is lost. The deep, which the Earth made on its own, remains. With that much time available, the question stops being whether the planet survives. The planet survives. That part, in the only sense that matters, is settled. The planet keeps going for a span so long that the word survival starts to feel too small for it. The question becomes where the planet goes, not what happens to it, what it crosses. Because given enough time, even a slow planet covers a lot of galaxy. Tens of thousands of years pass in this sentence. Earth, dark and frozen and internally warm, drifts through interstellar space. The nearest star in any direction is more than a light year away. There is no day. There is no night in the old sense, because there is no sun to set. There is only the slow black crossing, the planet moving through the medium between the stars at a speed that has not changed since it left the Oort cloud. This is the voyage, not a fall into emptiness, a passage through a populated medium on a defined trajectory at a measurable speed, across distances that take so long to cross that the words for them stop meaning anything ordinary. The earlier part of the story imagined Earth as a single, isolated object, alone in the dark. That image is incomplete. Interstellar space is not empty. It is thin, almost unimaginably thin. But it is not nothing. There is gas out there, hydrogen mostly, a few atoms per cubic centimetre in the densest regions, far less in the voids between. There is dust, fine grains of carbon and silicate scattered through the gas. There are clouds, vast diffuse structures of slightly denser gas, light years across, drifting through the galaxy on their own slow currents. And there are the stars, sparse but real, each one with its own gravitational reach, each one moving on its own orbit around the galactic centre. The Sun itself is moving through one of these clouds right now. The local interstellar cloud, a wisp of slightly denser gas about 30 light-years across, which the solar system is currently passing through and will continue passing through for the next 10,000 to 20,000 years. The Sun is not stationary in some fixed empty space. The Sun is in motion, drifting through interstellar matter, the way every star is, the way an ejected Earth would be. The drift of a rogue planet through the interstellar medium is not exotic. It is the normal motion of everything in the galaxy. The Sun does it, the stars do it. Earth, ejected, would simply be doing it without a star to do it alongside. At 30 kilometers per second, which slows to roughly 24 once the Sun's gravity stops mattering, Earth crosses 1 light year in about 10,000 years. 1 light year, 10,000 years. That ratio is worth holding on to, because it sets the scale of everything that follows. The distance light covers in a year, the distance that took the photons from the nearest star 4 years to cross, takes the Earth 10,000. The galaxy is built on distances that make a planet's velocity look like standing still. To reach the distance of Proxima Centauri, the nearest star to the Sun at 4¼ light years, would take the ejected Earth about 42,000 years if the trajectory happened to point that way. 42,000 years to reach the nearest star, and the nearest star is close in galactic terms, almost absurdly close. The galaxy is 100,000 light years across. A planet crossing 1 light year every 10,000 years would take 1 billion years to cross the galaxy once, and the galaxy is turning the whole time, so the crossing would never be a straight line anyway. The Earth, on its voyage, is not going anywhere in particular. It is moving through a structure so large that even deep time barely advances it across the map. Right now, as you're listening, an object launched from Earth is already doing a slower version of this. Voyager 1, which crossed out of the Sun's bubble of influence into true interstellar space in the early 2010s, is moving outward at about 17 kilometers per second. It will not reach the distance of even the nearest star for tens of thousands of years, and it is not aimed at one anyway. It is simply drifting outward into the same dark and ejected Earth would cross, a small piece of metal on a trajectory that will outlast the civilization that built it by an almost unmeasurable margin. The planet, ejected, would be doing what Voyager is doing now on a far grander scale, carrying not a probe but a whole world, not a few instruments but a sealed living ocean, out along the same kind of one-way path through the same kind of dark. Here is the number that has not changed: 30 kilometers per second. The speed Earth carried in orbit, the speed it has had its entire existence, the speed that with the sun's gravity made a closed curve and kept the planet home. That same speed, with the sun's gravity gone, now carries the planet across a light year every 10,000 years. The number is identical, the meaning is reversed. It was the speed of staying, it is now the speed of leaving. The velocity that meant home means distance, same value, opposite direction. The planet did not speed up to escape. It used the speed it always had, pointed the other way. A single instrument carried through different concert halls. The instrument is the same. A violin is a violin in any room, but the sound it makes depends on the room. In a small wooden hall, the note is warm and close. In a vast stone cathedral, the same note rings and echoes and hangs in the air. In an open field with no walls at all, the note is thin and quickly gone. The instrument does not change. The acoustics around it do. Earth on its voyage is the instrument. The planet is the same planet, the same mass, the same internal heat, the same sealed ocean, the same warm vents. What changes is the medium around it. For most of the voyage, Earth moves through the thin near vacuum between the stars, where there is almost nothing, and the planet's passage leaves no mark and draws no response. Then, sometimes, Earth drifts into a denser interstellar cloud, where the gas is thicker, where the dust is heavier, where the planet's leading face sweeps up a faint accumulation of interstellar material. The note bends slightly as the room changes, then the cloud thins out behind it, and the note goes quiet again, and the planet continues through the next long stretch of nothing. The clouds do not harm the planet. Even the densest interstellar cloud is more rarefied than the best vacuum ever produced in a laboratory on Earth. The planet sweeps through them the way a stone sweeps through fog, gathering a film, leaving a wake, unchanged in any way that matters. But the clouds mark the voyage. They are the rooms the instrument passes through. They are the only events, for long stretches, that distinguish one 10,000-year span from the next. There is a scale to the galaxy that the voyage slowly reveals. Earth, ejected from somewhere in the disk, drifts through a structure shaped like a flattened spiral, 100,000 light-years across and only a few thousand thick, with the sun and most of the stars riding within the thin, bright plane of it. If the ejection happens to point Earth out of the plane, the planet climbs upward, out of the crowded disk, into the sparse halo above it, where the stars thin out and the dark grows deeper, and the few objects that remain are old, scattered globular clusters and lone ancient stars left over from the galaxy's youth. If the ejection points Earth along the plane, the planet stays among the disk's denser traffic, threading between spiral arms, crossing regions where stars are being born in bright clusters and regions where nothing has formed in billions of years. The trajectory was set by a single random geometry at the moment of ejection, and that geometry decides which galaxy the planet crosses, the crowded plane or the empty halo, for the rest of its long voyage. Either way, the planet is carried by the galaxy as much as it carries itself. The whole disk is rotating, the sun and stars and gas all turning together around the distant galactic center, a single immense wheel taking hundreds of millions of years to complete one turn. A rogue Earth, even free of the sun, is not free of the galaxy. Its trajectory is laid over the galaxy's rotation, the way a person walking across the deck of a turning ship moves both by their own steps and by the motion of the ship beneath them. The planet's path through interstellar space is real, but the space itself is moving, and the planet rides that larger motion without any say in it. Across hundreds of millions of years, the planet's voyage and the galaxy's rotation combine into a path no straight line could ever describe, a slow curve laid over a slow wheel, the planet going where it points and where the galaxy carries it at the same time. Go up to the surface in this stretch of the voyage and look for the sun. You will not find it, not with your eyes, not even knowing which way to look. The sun by now is one of thousands of stars in the sky, and not a notably bright one. It has receded so far that its light, which once filled the daytime sky and powered every living thing on the surface, is now a faint point indistinguishable from countless other faint points. It is in a known direction, it is at a known distance. The geometry of the ejection, integrated forward, says precisely where it is. But the sky does not confirm what the geometry knows. To find the sun now, you would need a telescope and a star chart and the prior knowledge of exactly where to point. Without all three, the sun is simply gone, folded invisibly into the background of a galaxy that looks the same in every direction. The star that gave this planet its name and its seasons and its history, the star that was for 4.5 billion years the single most important object in the Earth's sky, cannot be picked out from the others. It has not died. It is still burning, still doing what it has always done, still warming the planets that stayed behind. It is simply too far away, and the Earth, looking back, can no longer tell which light is its own. For most of the voyage, there is nothing. The planet crosses light year after light year of thin dark space, century after century, age after age, and encounters nothing larger than a drifting cloud of gas. The voyage is, overwhelmingly, a story of emptiness. The galaxy is mostly space, and space is mostly empty, and a planet crossing it spends almost all of its time crossing nothing at all. But the galaxy keeps moving too. The stars are not fixed. They orbit the galactic center, the sun among them at speeds of hundreds of kilometers per second, on paths that bring them over hundreds of millions of years into new arrangements. The constellations themselves are temporary. The patterns in the sky drift and dissolve and reform on timescales longer than human history, but far shorter than the lifetime of a rogue planet. Earth, drifting on its slow trajectory, is moving through a galaxy that is itself in constant motion. The stars come and go around it. Some recede, some, over the long stretches of deep time, approach. And sooner or later, on a voyage measured in hundreds of millions of years, something passes close. A point of light growing. Not quickly. Over 1,000 years, a single star in Earth's sky brightens by a degree that no instant could capture, a swelling so slow that it would take generations of watching to confirm. The planet, on its long dark trajectory, is approaching another star, not on a collision course, at an oblique angle, the way two travelers on different roads might, for a stretch, find their roads converging before they diverge again. The star ahead is growing because the distance is closing. For a while, the distance will keep closing, then it will open back up. Millions of years have passed since ejection. The planet that was never supposed to last this long has lasted, its deep ocean still liquid, its core still hot, its frozen surface still sealing in the warmth. And in those millions of years, the galaxy has turned, and the stars have moved, and the Earth has crossed enough of the dark that the law of large numbers has finally produced an encounter. The question that has been hanging since the start, the long loop, is whether the planet ever meets anything. Whether the voyage is pure isolation, forever, the planet drifting alone until the heat death of the universe, or whether, out there in the populated dark, something eventually crosses Earth's path closely enough to matter. The answer is that it does. Not often, not soon, but over deep time, inevitably, the planet has close encounters with other stars. The Milky Way is dynamic. Every star in it is moving, the sun included, orbiting the galactic center at about 220 kilometers per second, completing one orbit roughly every 230 million years. The stars do not move in lockstep. They drift relative to one another, faster ones overtaking slower ones, stars on different orbits passing through each other's neighborhoods. Over hundreds of millions of years, any given object in the galactic disk, including a rogue planet, will have multiple encounters with other stars, where encounter means a passage within a few light years. A few light years is not close by the standards of a solar system. It is enormously far, but it is close enough that gravity, which never reaches zero, has something to say. A star passing within a few light years tugs on the rogue planet, just slightly, the way the distant red dwarf once tugged on the Oort cloud at the very beginning of this story. Most of these tugs do nothing. They nudge the trajectory by a fraction of a degree, and the planet continues, slightly redirected, otherwise unchanged. The galaxy is full of these gentle, inconsequential near misses. They are the ordinary texture of a long voyage. The galaxy already does this, and it is doing it to the Sun right now. The star Gliese 710, currently about 53 light-years away, is moving toward the solar system. In roughly 1.33 million years, it will pass within about 1/10 of a light-year of the Sun, deep inside the Oort cloud. Closer than any known star will come in that span. When it passes, its gravity will stir the comets of the outer solar system, nudging some of them onto new orbits, sending a slow rain of them over the following millions of years toward the inner planets. This is not a hypothetical for some distant rogue world. This is the Sun's own near future. The galaxy does this to every star. The galaxy has always done this. An ejected Earth drifting through the disk would simply experience the same kind of encounter from the other side as the lone objects rather than the system being approached. 300,000 years into the voyage, Earth, dark and silent, drifts toward a red dwarf at an oblique angle. The star has been a point of light in the sky for a long time, one among many, but now it is growing. Over centuries, it brightens, first into a noticeably brighter point, then into the brightest object in Earth's sky since the Sun itself was lost. For a few decades near the closest approach, the star is bright enough that its light, falling on the frozen surface, registers as a faint warmth on the side of the planet that faces it. Not enough to melt anything. The surface ice, hundreds of degrees below freezing, picks up a thermal signal from the passing star. A few degrees of warming on the sunward face, a faint flush of energy on a world that has felt nothing from the sky in 300,000 years. The frozen nitrogen does not sublime. The water ice does not soften. The deep ocean, 2 miles down, does not register the visitor at all. The warmth is too little, too brief, too far. It is a gesture, not an event, a star leaning close enough to be felt and not close enough to change anything. Then the geometry continues. The closest approach passes. The star, which had been growing for centuries, begins to recede. The faint warmth on the sunward face fades. Within a few more centuries, the red dwarf is once again just a bright point among the others, and then just a point, and then one more star in a sky full of them, dimming back into the background as the distance opens. The encounter happened. The encounter is over. No mark was left on either side. The star did not know the planet was there. The planet, having no one to know anything, simply continued. The silence of it is the weight of it. Two objects, a star and a world, passing within reach of each other across the dark, and nothing is exchanged, no signal, no contact, no record made on either side that the other existed. The star burns on toward wherever its orbit takes it. The planet drifts on toward wherever its trajectory points. They will never come this close again. They were never aware they came close at all. Most encounters are like this. A slow approach, a brief brightening, a gentle gravitational tug, a slow recession, and nothing changed. But not all of them. The gravitational tug, in a small fraction of encounters, is enough to redirect the planet's trajectory by a meaningful amount, bending its long voyage onto a new heading. And in a far smaller fraction, a vanishingly small fraction, the geometry of an encounter is just right for something more. Capture. For a rogue planet to be captured by a star, to be pulled out of its interstellar drift, and into orbit around a new sun requires a very specific and unlikely set of conditions. The planet has to pass close enough, slowly enough, and with the right geometry, often requiring a third body, another planet or a companion star, to absorb the excess energy that would otherwise carry the rogue back out. The odds of all of this aligning in any single encounter are extremely small, but the voyage is long. The encounters accumulate, and small probabilities, multiplied across enough attempts and enough time, stop being negligible and start being statistics. Over the lifetime of the galaxy, the most likely outcome for a rogue Earth is that it remains rogue. It drifts encounter after encounter, none of them quite right for capture, crossing the dark for billions of years, never bound to anything again. That is the probable fate. The planet stays free, stays dark, stays alone, its deep ocean outliving the surface by an eon, its voyage outliving the ocean by far longer, until eventually the internal heat finally runs down, and even the deep sea, after hundreds of millions to billions of years, freezes through at last. Less likely, but not impossible, is capture. An encounter with the right geometry, most plausibly with a low-mass star, a red dwarf, pulling the rogue Earth into a wide, distant, frigid orbit, a new sun, dim and red, hanging in the sky of a planet whose surface is far too cold for that distant warmth to thaw. The planet would have a star again, but it would not have a day, not a real one, not enough light or heat to undo the long freeze. It would be a captured world, technically bound, practically unchanged. A dark planet now orbiting a dim star at a distance where the star is little more than the brightest point in a still frozen sky. Imagine that outcome carried far enough. A rogue Earth, captured after a billion years of drifting, settling into a wide, slow orbit around some small red star in a part of the galaxy the sun never came near. The new star would be too dim and too distant to melt the surface, but over an immense span of time, depending on the orbit, it might deliver just enough warmth to slow the planet's final cooling, to extend the life of the deep ocean by some increment, to keep the vents running a little longer than they would have run alone. The planet would have a sun again, of a kind. It would not be the sun. It would be a stranger, a faint red companion to a world that had already crossed half the galaxy alone. And it would change almost nothing about the frozen surface or the sealed sea, but it would mean the planet's voyage had ended not in isolation, but in a new, distant, dim belonging. A second system, a second star, a planet that had been cast out of one family quietly adopted, ages later, by another. And least likely of all, statistically negligible, but not strictly zero, is the violent ending. An encounter not with an ordinary star, but with a stellar remnant, a white dwarf, a neutron star, a black hole, objects that drift through the galaxy the way everything else does, dark and dense and dangerous. A close enough pass with one of these would not be a gentle tug. The tidal forces near a neutron star or a black hole are enormous, capable of stretching and tearing a planet apart, pulling it into a stream of debris that would spiral down and be consumed, fast, total, final, the one ending in this entire story that actually destroys the planet rather than transforming it. And the rarest of all the outcomes, the one least likely to ever happen, a chance so small across even the lifetime of the galaxy that for almost every rogue world, it never comes. A clock keeps ticking in an empty room. The hands move. Nothing in the room watches them. No one winds it, no one reads it, no one is there to mark the hours it counts. And still the hands move, because the mechanism inside it does not require an audience to run. The motion is real, whether or not anything observes it. The rogue Earth, drifting through encounter after encounter, across hundreds of millions of years, is a clock in an empty room. The stars pass, the trajectory bends or holds. The deep ocean keeps its slow currents, and the vents keep their slow chemistry, and the core keeps its slow churn, all of it ticking forward, none of it witnessed, the planet keeping perfect time in a galaxy that has no one assigned to watch it. This is the resolution of the question planted earlier, the thing not yet said, the journey that does end. It ends for almost every rogue planet, not in destruction and not in capture, but in the slow running down of the internal heat, billions of years from now, long after the surface died, long after the sun became invisible, long after every star that the planet ever passed has itself burned out or moved on. The voyage does not end at a destination. It ends at a temperature. The day the core finally cools enough that the deep ocean freezes through to the bottom, and the last warm water becomes ice, and the last vent goes cold, and the chemistry that ran without the sun for billions of years finally has nothing left to run on. That is the ending, not a crash, not a capture. A planet, somewhere in the dark, finally going cold all the way through, ages after anyone could have watched it happen. The imagination expected an ending that was sudden and dramatic and soon. The real ending is slow and quiet and almost unimaginably far away in time. The planet does not die when the sun leaves. The planet dies when its own heart finally stops, and its own heart is good for billions of years. After enough of these encounters, after enough drift, after enough deep time, Earth is no longer recognizable as the thing it once was. Not because it changed, the planet is almost entirely unchanged. The same rock, the same iron, the same sealed sea. It is unrecognizable because there is no longer anywhere to refer back to. The solar system it came from is light years behind and falling further away every century. The sun it orbited is one anonymous point among millions, findable only by calculation. The constellations that once framed the sky have drifted and dissolved. There is no home left to be measured against. The planet is the same. The context is gone. By then, the sun is not just out of sight. It is out of relevance. Pull back, further than this story has pulled back at any point. Past the planet, past the encounter, past the single trajectory, until a whole region of the galaxy is in view, a field of stars, marked as points of light, scattered across the dark with vast distances between them. That is the galaxy as it is usually pictured, light and the black between them. Now add what the picture leaves out. Between the marked stars, in the dark that looked empty, place the rogue worlds, hundreds for every star, thousands. Dark dots filling the spaces between the lights, far more numerous than the stars they drift among. Invisible because nothing lights them, present because the physics says they must be. The galaxy that looked like scattered lights on black is actually mostly the dark dots. The lights were always the minority. The dark was always the rule. Earth is one of the dark dots now. The story began with a single planet and a single fate, and it felt at the start like something rare and unprecedented, a catastrophe befalling one world. It is not rare. That was the expansion, back near the beginning, when the census first appeared, and it returns now with full weight. Earth, ejected, has not become something unusual. It has joined the majority population of the galaxy. It is no longer the protagonist of a journey. It is a data point in a census. One member of a population that has been there the whole time, older than the sun, more numerous than the stars, almost entirely unseen. There are more rogue planets in the Milky Way than there are stars. The estimates run into the trillions. We have directly detected fewer than 100 of them. That ratio between what exists and what has been seen is one of the widest in all of science. The population is real. The population is enormous, and the population is, for the most part, permanently beyond the reach of detection. A single cubic light year of interstellar space. Somewhere midway between two stars, a volume of the galaxy chosen at random, far from anything bright. Look into it with the best telescope ever built and you would see nothing. No light comes from it. It is to every instrument empty. It is not empty. Suspended in that volume there is gas, thin hydrogen, a few atoms per cubic centimetre. There is dust, fine grains drifting on the slow currents of the interstellar medium. There are slow particles, cosmic rays threading through, and somewhere in it, or in the next volume over, or the one after that, there is a rocky world, maybe more than one, drifting, dark, internally warm perhaps, sealed perhaps over a deep liquid sea, and utterly undetectable from where anyone stands. The telescope shows nothing, because the telescope cannot show this. The world emits no light to be seen by. It betrays itself only in the rarest of circumstances, when it happens to pass directly in front of a more distant star and bend that star's light for a few brief weeks. The rest of the time, always, it is simply there, unseen. The same is true of the next cubic light year, and the next 10,000 in every direction. The galaxy is built this way, sparse lights in a sea of dark worlds, and the listener, who began this story picturing a galaxy of stars, has to reckon now with a galaxy that is mostly the thing between the stars. The dark is bigger than the light. It always was. The instruments simply could not see it, and so, for most of human history, it was not there. Every map of the galaxy ever drawn is a map of the lights. The spiral arms, traced in bright young stars, the galactic core, glowing with the packed light of billions of suns, the constellations, the catalogues, the surveys, all of it built from the things that shine. None of it shows the dark worlds, because none of it can. A true map of the galaxy, one that showed every object large enough to be called a planet, would not look like the familiar pinwheel of light at all. It would be denser, dimmer, and far more crowded. The bright stars almost lost in a fog of dark dots, far more numerous than they are. The galaxy people picture and the galaxy that exists are not the same galaxy. The pictured one is the Minority Report. The real one is mostly dark, mostly drifting, mostly unseen, and now, somewhere in it, holds the planet that used to be home. This is the fact underneath all the others, the one the whole story has been moving toward. Almost everything anyone has ever learnt about the universe was learned because something was lit. Stars, because they shine. Galaxies, because they are full of stars that shine. Planets around other stars, almost always, because they pass in front of a star that shines, or tug on a star that shines, or reflect the light of a star that shines. The entire enterprise of knowing the universe has been, at bottom, the study of things that emit or reflect light. A planet without a star emits almost nothing and reflects almost nothing. A planet without a star is by default almost impossible to know about. The galaxy is full of things that are not lit, full of worlds that crossed into the dark and disappeared from the only kind of knowing that telescopes can do. The rogue planets are the largest known example, trillions of them, almost all unseen. But they are not the only example. The universe is full of what is not lit, and the lit part, the part that fills every textbook and every image and every map of the cosmos, may be the smaller part. The things we have not learnt, and never will, may outnumber the things we have, by a margin as wide as the dark is wide. Earth, ejected, becomes one of these unlearnable things. Its biosphere, if it persists, sealed under 2 miles of ice, fed by vents in a deep black sea, would be entirely undetectable from any distance. There is no signal a frozen surface sends. There is no light a sealed ocean leaks. The microbial mats would grow. The worms would feed. The chemistry would turn over. All of it real, all of it alive, all of it utterly invisible to any observer anywhere. A living world passing through the galaxy, with no way for anyone to ever know that it lived. The disturbing part is not Earth's particular fate. It is the implication that follows. If Earth, ejected, would carry a hidden living ocean through the dark with no way for anyone to detect it, then every one of the trillions of rogue worlds out there is a question that cannot be answered. Most of them, certainly, are dead, frozen through, never alive to begin with. But the physics that would keep an ejected Earth's deep ocean liquid for billions of years is not unique to Earth. It is just rock, water, and radioactive heat. Any rogue world large enough, with water and an internal furnace, could in principle hold a sealed sea in the dark, warm at the bottom, the way Europa does, the way an ejected Earth would. Some fraction of the trillions, some small fraction might, and there is no way from here to ever know which. The Sun by now is only a calculation. Given an ejection date, a direction and a velocity, the geometry says exactly where the Sun is, how far, in which direction, at what relative speed. The math is not difficult, anyone could do it. The numbers are precise, and nothing in the sky confirms them. You can calculate where the Sun is to the kilometre, and you can look in exactly that direction with your own eyes, and you will see only stars, none of them distinguishable from the rest, the Sun lost among them, present in the arithmetic, and absent from the view. The known and the visible have come apart. The numbers say one thing, the sky says nothing. There is a calculation, simple enough that anyone could do it, that says where the Sun is. Given an ejection date, a direction, a velocity. The math is not difficult. Earth, somewhere in the dark, travelling at 30 kilometers per second, knows exactly where its old star is. Or, the rocks know, the frozen oceans know, the instruments would know, if any instrument still worked. The numbers are still there. The numbers do not stop being true. But the Sun is not visible. Not because it is gone, it isn't, it is still burning. It is still doing what it has been doing for 4.5 billion years. It just happens to be too far away, and in the wrong direction, and lost in a field of stars that all look the same now. From the surface of a planet that used to be the third one out, the Sun is not findable. This is what becomes of an ejected world. Not destruction, disappearance. Somewhere, right now, there is a planet very much like this one, rocky, layered, with an iron heart and a frozen sea that was ejected from its star 10 billion years ago. It has been crossing the dark for longer than the Earth has existed. Its oceans are still there, beneath ice older than our solar system. Whatever happened in those oceans before the Sun was lost, whatever began to move there, is either still moving, or stopped, or has become something we have no name for. We will not find it. We almost certainly cannot. But the calculation is simple. The numbers don't go away. And the galaxy keeps making more.